All right, as we get this fired up, we're going to be talking about something called Hess's law in this video. We've kind of hinted at this before, okay? And we saw some things we can do. Like when we talked about thermochemical equations, we talked about how we could manipulate those things, right? We did this. Do, do. Okay, where we said that the phase labels mattered, that we can multiply and divide by a factor, and that we can reverse the equation, right? Multiplying and dividing, we can multiply and divide the delta H. Reversing the equation, we can flip the sign. We've done these things before, but these skills are necessary when we're thinking about applying what's called Hess's law. Okay, so let's look at some examples here, and I'm going to do this generically so we can kind of see what we're doing. Let's say that we have an initial equation that is A plus 2B makes 3C. This guy has a value of delta H1, okay, just because that's the first delta H we did. Okay, let's say we do a second equation, and this equation is 2A plus 4B makes 6C, and this has a delta H of delta H2. Delta H2, if you look at this, what we did is we took the first equation and we multiplied it by 2. Okay, so that would mean our delta H2 is really 2 times delta H1. Okay, we can do another thing and go through and say, okay, let's take our first equation, but now we're going to divide it by 2. Okay, that's going to give us half of an A and 1B and 3/2 of a C. Okay, and that's going to give us delta H3, which is equal to 1/2 of delta H1. So what we're saying here is if you're multiplying or dividing by a factor, then you just have to multiply or divide your delta H by the same factor. Okay. Let's take now our original equation and let's flip it over. As I flip it over, we're going to do it backwards. So take 3C and it decomposes into an A and 2B. We'll say this guy has a value of delta H4 that is equal but opposite of delta H1. So mathematically, we can say this, we're just multiplying it by -1, okay, when we do that. All right. Now, this is all how we can manipulate equations. Hess's law itself talks about adding equations together. Okay, so let's see what this means. What do I mean by adding equations together? Let's take a green equation, and we're going to use new values here. So this will use D plus 2E gives us 2F, and we'll say this guy has a value of delta H5 because this is the fifth equation in my set of examples. And we're going to add to that a blue one. This blue one is 2F plus a G will make an H and an I, and this is, we'll say delta H6. Okay. Now, we can add these equations together. Okay, that's what we're going to do. We're going to add these equations together. And if we look, there are things on each side. We can think of this the same way as spectators, right? There's 2 F's here, but there's 2 F's there, so they're going to cancel out. Okay. So now there's stuff that's left over, and the stuff that's left over is our net overall equation. So that's D plus 2E plus a G gives us an H plus an I. And we'll say this equation has a delta H of delta H7. Now, because we added this equation, the green equation, and the blue equation, our delta H7 is equal to delta H5 plus delta H6. Because if we added the equations together, we can add together the delta H's. Okay. Visually, it's like this. Okay. Our delta H5 is this, right? We went from D and 2E and we turned it into F and G. Okay. Well, F really. G, we added G into it, and we had G and F, oh shit, sorry. We had G and F turn into H and I. That's delta H6. So if we went up by this much and down by this much, that means net, we went down by a little bit, okay? And overall, delta H7 is the conversion of D plus 2E to H and I, okay? This is what Hess's law is saying. We can phrase this in words. If a reaction is performed over several steps, its enthalpy of reaction is the sum of the enthalpy changes of all the steps, okay? A lot of this is, I think of this as like thermochemistry puzzles, right? Can we manipulate the pieces to add up to give us an equation that we're looking for, okay? And we're going to give that a shot, okay? So here's an example. Say we want to know the delta H for this reaction, okay? Carbon plus water gives us carbon monoxide and hydrogen gas. Okay, we want to know the delta H for this equation. So we can figure that out. We have three equations in our data set, 1, 2, and 3. Okay, and we're going to work our way through this. The way I tackle this is to look at the data set we have and find everything in the equation we're looking for in the data that we have. Okay, we have carbon solid, so there's a carbon solid. We have water gas, so there's water gas. Okay, we have CO, that's CO2. Oops. There's the CO. Okay, and we have hydrogen, there's the hydrogen. Okay, now the goal is, can we manipulate our equations, right, by adding them, not by adding them, by multiplying by a factor, dividing by a factor, or flipping them over so they add together to give us that. Okay, if we look, our green equation here has carbon in it, carbon solid. There's one carbon solid here, there's one carbon solid there, so we can just do nothing to this one, right? We're going to keep it the way it is, okay? On this equation in the middle, we have one CO on the right, but this is two COs on the left. So what we're going to do is we're going to flip this, and we're going to divide by 2, okay? So we're going to take this thing, and we're going to multiply it by -1/2. That's the same thing as dividing by 2. The negative is to flip it over, okay? In our third one, here, we have one hydrogen on the right and one water on the left. This has 2 waters on the right and 2 hydrogens on the left. So we're going to do the same thing here. We're going to flip this, and we're going to divide by 2. So that's the same thing. We're going to take this delta H, and we're going to multiply it by -1/2. Okay. So ultimately what this means we're doing is we're going to take these delta H's and add them together. So our delta H that we're looking for is equal to -393.5 with nothing done to it, kilojoules, okay, plus -566.0 kilojoules times -1/2 plus -483.6 kilojoules times -1/2. Okay, now we can math this out. -393.5 kilojoules plus, where am I at? This one flipped over and divided by 2 is 283.0 kilojoules. That's positive. Okay, this is also going to be positive now, plus 483 flipped over and divided by half is 241.8 kilojoules. And now we can just add all those guys together, and we get positive 131.3 kilojoules. That's our answer. Okay, you don't necessarily need the positive on there, but you need to have the 1 decimal place on there for significant figures. Okay, it's a puzzle we're trying to figure out. Let's look at another one. All right, so now we want to get this equation. 3 carbon solid plus 4 hydrogen give us a propane. So this is propane. So I'll probably say propane versus C3H8, but you know what we're talking about. And we have 3 data sets here again. Let's use the data we have to figure this out. Okay, find all of our knowns that we're looking for. Carbon solid, hydrogen gas, and propane. Okay, again, we're going to manipulate our data to make it so that we add up to this equation and everything else goes. Okay, so what I should have done is had more room and written this out so we can see the things canceling out, but we'll try to do that on this one. Okay, all right, so what do we got? All right, so here we have 1 propane on the right, and this is 1 propane on the left, so all we have to do to this one is flip it over. Okay, which means we'll take this one and do -1. Okay, in the second one, we have 3 carbon on the left. This is 1 carbon on the right. So this one we're going to multiply by 3. So we're going to take our delta H and multiply it by 3. In the last one, we have 4 hydrogen on the left, and we have 2 hydrogen on the right. So this one needs to get multiplied by 2, so we can do that. Okay. Now, before I play with delta H's, let's do what we said we're going to do. I should have done that on the other one, but here we go. So number 4, if we flip it over, is going to look like this. 3 CO2 gas plus 4 water gas gives us propane, C3H8 gas, and 5 O2 gas. This delta H then is positive 2043 kilojoules. Okay? -1 times a negative number. There we go. In our second one, number 5, we're just going to multiply this dude by 3. So 3 carbon solid plus 3 O2 gas gives us 3 CO2 gas. Okay? This delta H is that delta H times 3, which is negative 1180.5 kilojoules. Okay. All right, this number is a whole number. This has 4 significant figures. Right. That has 4 significant figures. All right. Let's do the next one. Take number 6, and we're multiplying it by 2, so that gives us 4 hydrogen gas, 2 O2 gas, and 4 water gas. And this delta H is 2 times that, which is negative 967.2 kilojoules. All right. Now, if these really add up, then all of the things we don't want will cancel out, and the things that we do want will stay there. Okay. So let's start canceling. We need the water, the carbon, and the propane to stay in the hydrogen. No, the water's canceling out. I'm sorry. Let's cancel something. Cancel it. Oh my gosh, my brain. Ah. Okay. 3 CO2s here, 3 CO2s there, cancel out. 4 waters here, 4 waters there, cancel out. 5 O2 there, and 3 plus 2 is 5, so that cancels out. Everything canceled. We're left with 3 carbon solid plus 4 hydrogen gas make a propane, C3H8 gas. Okay. This equation matches the one we're looking for, so that's good. Our delta H then is the sum of all of those things put together. So the delta H answer we're looking for here is negative 105 kilojoules. Okay. That's how Hess's law works. Feel free to bug me about this. If you have questions or need anything, I'm here. Um, Remember to add your equations, make sure you're flipping stuff around and finding all your things. Keep your units going. Okay. I'll catch you later.